everybody, I'm Miss Cooksey, and today we're going to be talking about some of the reasons for proofs. In particular, we're going to be talking about algebraic proofs. So these are the ways that we prove that the algebra that we've done in previous courses is correct and accurate. This is a great introduction to proofs because it starts with something that we're really familiar with, like algebra. So to kick things off, we need to go ahead and define a bunch of properties. These are going to act as our reasons for every step that we do along the way. So the first property is the addition property of equality. This says that if A equals B, then A plus C equals B plus C. This is what allows us to add the same thing to both sides of an equal sign. We then have the same thing for the subtraction, multiplication, division properties. If A equals B, then A minus C equals B minus C. If A equals B, then A times C equals B times C. And if A equals B, then A divided by C equals B divided by C. These four properties, are what allow us to do the same thing to each side of the equal sign. These are the foundations for all of those undoing and inverse operations that we learned about in Algebra 1. Next up, we have the reflexive property of equality. The reflexive property of equality says that A equals A. This says that if just because it's on a different side of the equal sign, it's equal to itself. This relates a lot to the symmetric property of equality, which tells us that we can flip things around an equal sign. So if A equals B, then B equals A, and the reverse is also true. The transitive property of equality says if A equals B and B equals C, then A also equals C. I like to think of this as the dollar menu property. So if a Coke is $1 and fries are the same price as a Coke, then fries are also $1. The substitution property of equality says if A equals B, then A can be replaced by B. So this is the property that allows us to do the substitution method when we're solving linear systems of equations. This is also what allows us to plug in numbers when we're evaluating expressions. If we know that two values are equal, we can replace them. Last but not least, we have the distributive property. So A times B plus C equals A times B plus A times C. These are all the properties that we are going to use to help us prove algebraic statements. So let's break down a proof. We always start with a given statement. So in this case, our given statement, let me make my pen smaller, is 3 plus 4 times x minus 2 is equal to 27. This is always the first piece of information that we are going to use to solve. We always want to end with the statement that we're trying to prove. So we need to figure out, how do we get from point A to point B? Well, let's start with this given statement. The first thing I'm going to do is actually subtract 3 from both sides of the equal sign. So that gives me 4 times x minus 2 equals 24. So this is the subtraction property of equality. Next, I'm going to divide both sides of my equal sign by 4. So that leaves me with x minus 2 equals 6. So that would be the division property of equality. Finally, I'm going to add 2 on both sides. So that's the addition property of equality. And I get x equals 8. Notice how prove is never a reason. The only reason from the beginning we have is what's given. Then we need to use all of these reasons to get us from point A to point B. If you looked at this and said, oh, like I would have distributed first and then I would have combined like terms, those are totally appropriate reasons. We're just trying to find the shortest method possible here. Next up, we have the measure of angle 3 equals the measure of angle 4. And the measure of angle 4 equals the measure of angle 5. So that is our given. And we want to prove that angle 3 is congruent to angle 5. Well, from the transitive property, we can then learn that the measure of angle 3 is equal to the measure of angle 5. That's what the definition of the transitive property tells us. That if this is equal to this and this is equal to this, then these two have to be equal. Then, to convert from the measures of the angles to the fact that the angles themselves are congruent, we're going to use the definition of congruent angles. This is our proof. Oops, my light's turned off. Let's look at two more examples. So we're going to start here. And we have that 2 times x plus 2 is equal to 0.5x plus 1. This is our given. And we want to prove that x equals negative 2. Well, the first thing that we can do here is the distributive property. So 2x plus 2 equals 0.5x plus 1. So this is the distributive property. After that, I'm going to subtract 0.5x from both sides. So 1.5x plus 2 equals 1. So that's the subtraction property of equality. Next, I'm going to subtract 2 from both sides. So 1.5x equals negative 1. Oh, I don't even need that extra step. So that is going to also be the subtraction property of equality. Then I'm going to divide both sides by 1.5. Did I copy that down wrong, right? Oh, I distributed wrong. So this should have been 2x plus 4. It's like my math is not working. Then I'm going to divide both sides by 1.5, and I end up with x equals negative 2. That looks confusing. Let's get rid of that. Okay, in our last example, we have all this given information. So we're going to break it up a little bit. We are going to take angle A is congruent to angle B. Angle B is congruent to angle C. And then we know that angle A equals 3x minus 4, and angle C equals 4x plus 2. That is all of our given. So let's just focus on those first two statements. Well, if angle A is congruent to angle B and angle B is congruent to angle C, these are measures, then the measure of angle A is congruent to the measure of angle B, and the measure of angle B is congruent to the measure of angle C, is equal, sorry. When we use measures, we don't have congruence, we just have equals. So this is the definition of congruent angles. Now we're going to use the transitive property. So if these two things are equal and these two things are equal, then the measure of angle A is congruent, or is equal. I've not had my coffee yet this morning. To the measure of angle C. So this is the transitive property. Now that we're here, we're going to use substitution to substitute in these expressions for these angles. So 3x minus 4 is equal to 4x plus 2. That is substitution. Moving on, now we're going to use our properties of equality to solve. So I'm going to start by subtracting 3x from both sides. So negative 4 equals x plus 2. That's the subtraction property of equality. Then I'm going to subtract 2 from both sides. And I have negative 6 equals x. That's also the subtraction property of equality. Notice that my statement doesn't exactly perfectly match my proof right now. Negative 6 and x are on reverse sides of the equal sign. We need to flip them. So x equals negative 6, and we can flip them because of the symmetric property. Thanks for watching this video. I hope it was helpful. Make sure you subscribe so you never miss a video, and I'll see you next time.